And we have two presenters for our final paper. We've got Chris Lennon and Jim Doyle. Chris serves in Ross Video's Office of the CTO as Director of Standards Strategy. He is responsible for Ross's activity in standards and trade organizations, as well as its Global Thought Leadership Program. And Jim, as Vice President of Creative Services at Ross Video, leads an elite team of Expression and Unreal artists and developers who deliver cutting-edge visual solutions for a wide range of Ross clients. With the working title of Mission Commander, a very cool title, Jim oversees the business, marketing, sales, and production operations of Rocket Surgery, Ross's creative and professional services division.
Good afternoon. Thanks for sticking around. Chris won't be joining us. He's actually doing a concurrent presentation in another building, so you're stuck with me. So I hope that's sufficient. Let's see, where are we? All right, great. So in live television, timing is everything. Large events like election nights require precise coordination across video switchers, graphic engines, camera cues, and AR elements, all while reacting to constantly changing information. Over the years, graphics, rendering, automation, and real-time data feeds have made visuals more powerful and flexible, but control has stayed largely manual, which slows reaction time and adds to the cognitive load for both operators and on-air talent. That's why we at Ross Video and Rocket Surgery, we built a real-time voice control system designed specifically for broadcast. And this was in response to a customer request for an election night coverage. Instead of relying on control room operator to trigger cues, talent can now use natural language commands to directly control graphics and storytelling tools, hands-free and in real time. Unlike consumer voice assistants, voice control must be purpose-built for live production. It must understand broadcast context. It must integrate with active triggering protocols, working reliably in noisy environments, and respond with predictable low latency. In fact, during the 2024 election night, we used voice control to enable on-air talent to navigate complex graphics by voice alone, switching maps, clearing scenes, and interacting with data layers live on-air, but more on that a bit later. This is a glimpse into the future of production workflows, where hands-free voice control enhances speed, reduces latency, and unlocks new creative possibilities in news, sports, and beyond. So I'm Jim Doyle, Vice President of Creative Services at Ross Video. Today I'm excited to share how we're implementing artificial intelligence in a very real and practical way by putting AI-powered voice control into the hands of production teams. All right. So, commercially introduced at NAB during 2025, during the company keynote speech, voice control was shown in the context of weather graphics. Key action triggers are identified within the live transcription, and triggers are sent to a graphics engine, resulting in live advancement as seen on the program out. And I have a sample of that, I think. All right. Here we go.
Okay, I'm the guinea pig. Oh, on the right, we're showing Ross voice control, and it's listening to what I'm saying and reacting to it. And on the left is Raiden's video output. Okay, let's start with something simple, as I'm definitely an amateur meteorologist. How about we look at the current conditions at the airport just around the corner here in Las Vegas? Great, 70 degrees and sunny. For the evening ahead, we expect the winds to come down a bit and the temperatures to slide into the 50s, where we will start the day tomorrow. Let's jump over the pond to Europe to see what the weather is like at our Ross Video offices in Reading, UK, and Weisswitz, Austria. With that front in Central Europe pushing on, high pressure is settling in and will result in a very nice Sunday at our office locations. Now, did you know we're opening an office near Delhi, India? Let's see how things look in the morning there right now. It's clear and warm in Delhi, with folks on the East Coast keeping an eye on some cyclone potential in the Bay of Bengal. Coming back to North America, and notably our major locations in Canada at Iroquois and Ottawa. Tonight, the Ross team back at HQ are looking at a crisp 40 degrees. Now, let's come back again to Las Vegas, where the air is dry, the temperature is warm, and the drinks are flowing. For the week ahead, at the Great NAB Conference, we can expect a steady warm-up to the 90s on the last day of the show, with some clouds on Monday and Tuesday. Before I wrap up, let's take a quick peek into one of the more mysterious spots in the country, Area 51. We can't confirm what's going on there, but we can tell you the weather is 55 and windy. Not a UFO in sight, at least not on our radar. And back to you, Troy.
All right. All right. Very good. So voice interfaces are everywhere today, from virtual assistants in our homes, voice controls in our automobiles, but in live broadcast production, adoption has been slow. And that's because television workflows are uniquely demanding. They require split-second responsiveness, absolute reliability, and the ability to handle multiple overlapping commands. Traditional voice assistants just aren't built for that. Meanwhile, broadcast itself has only grown more complex. Producers now juggle real-time data, augmented reality graphics, and multiple video pipelines all at once. Even with automation, much of the control is still very manual. That slows things down and can limit creativity, especially in unscripted live environments. But advances in speech recognition and natural language processing are changing the game. Research has shown that domain-specific voice interfaces can actually rival traditional control systems if designed the right way. Voice control wasn't adapted from a consumer assistant. It was built from the ground up for broadcast. It's context-aware, redundant, operator-safe, and designed for predictable low latency. By narrowing the vocabulary and grounding it in real-time production state, it allows talent to drive visuals with their voice without sacrificing control or reliability. In short, voice control is about making live storytelling faster, more natural, and more creative while keeping the precision that broadcast demands. So, I think things are out of order here. All right. So, voice control is built as a modular low-latency system that lets natural speech control broadcast equipment in real time. At its core, it has four main parts: transcription, pattern recognition, control evaluation, and command dispatch. Each is tuned for speed, reliability, and seamless integration into a live production environment. Here's how it works. Audio from the talent's microphone is transcribed instantly into a custom real-time version of Whisper, an open-source ASR model proven to be reliable in noisy broadcast conditions. The transcription then flows into a pattern matcher, which detects potential commands using both phrase parsing and probabilistic matching. Let me see if I can find the right one. Nope. I think my slides got out of order. All right. So, next, the context engine evaluates the state of the show based on production state and feedback from the graphics engine. Finally, commands are dispatched through ROSHawk, dashboard, and WebSocket triggers, all with an average end-to-end latency of just 400 milliseconds. So, the system runs fully on-prem, containerized for security, and integrated natively into the ROS ecosystem. Operators always retain override control through dashboard, while Grafana telemetry tracks confidence, latency, and error rates in real time. So, our next case study was on election night deployment. So voice control had its first large-scale deployment during the 2024 U.S. election night broadcast. One of the most technically demanding live events of the year, the coverage ran for more than 8 hours straight, combining real-time results from over 10,000 data points with a fully immersive 3D graphics package powered by ROS Voyager. The goal was simple but ambitious: allow presenters to control graphics and data entirely by voice. Instead of relying on constant cues to the control room, talent could drive the storytelling directly, making the coverage faster, more interactive, and more spontaneous. So, during the broadcast, voice control continuously listened for natural commands. Phrases like, "Let's take a look at Fulton County," "Clear this," or "Show us the path to 270" were instantly transcribed. Evaluated against the live show state and routed to the correct graphic system, context awareness was key. If the anchor said Fulton County, voice control knew whether to pull up Georgia or Pennsylvania based on what was already on air. Across the full event, the system detected 351 on-air keywords. 42 of those triggered actual graphics changes, always intentional. There were 0 false positives and only 2 misses, both tied to ambiguous phrasing that was quickly addressed in post-analysis. So that brings us to the key advantages. The deployment of voice control in a major election night broadcast highlighted several key advantages of voice control workflows, particularly in high-pressure, high-visibility environments. Among the most notable benefits were reduced latency between creative intent and on-air execution, a significant reduction in operator workload, and enhanced freedom for on-air talent to explore content interactively. These benefits were especially apparent in unscripted moments, where the ability to trigger changes hand-free enabled more fluid storytelling and viewer engagement. So one of the biggest takeaways from the deployment was how voice control reduced bottlenecks in the control room. Normally, every graphic or camera change requires a cue from the producer, execution by an operator, and verification before going to air. Using voice control, many of those steps collapse. Presenters could trigger graphics or transitions directly by voice without breaking the flow of conversation. This streamlined the entire broadcast cadence. Talent could move more freely through AR environments, improvise with the audience, and react instantly to breaking news. Meanwhile, operators were free to focus on higher-level oversight, reducing errors and improving collaboration. And because voice control's architecture is modular, it's highly adaptable. So sports announcers could call up stats by voice, weather presenters could drive forecast maps, and even corporate events could use it for interactive branding or scene control. So, challenges and solutions. Despite its advantages, the deployment also revealed important limitations. Chief among these were edge cases and phrase ambiguity, variable microphone quality, and speech overlap in multi-host environments. While the system maintained a strong success rate, the 2 false negatives recorded during the election broadcast underscored the need for more robust disambiguation mechanisms, particularly in the presence of vague or indirect phrasing. To mitigate these issues, future versions of voice control will expand their pattern recognition engine to include semantic intent, classification, and phonetic confidence scoring, and the system will also incorporate speaker identification to support multi-user environments, enabling separate contextual models for different on-air talent. And we're hoping to be able to bring this to fruition within the next year. All right, so looking ahead, voice control's roadmap is focused on expanding both capability and reach. Future versions will support multilingual input, integrate more deeply with automation platforms, and introduce a cloud hybrid model to enable remote and distributed control. We're also exploring predictive control, anticipating talent intent from partial phrases or recent actions. Imagine graphics already preloaded before the command is even finished. So combined with subtle feedback cues like a quick visual or sound confirmation, this reduces cognitive load and gives presenters even more confidence on air. But the vision goes beyond features. What we're seeing is the start of voice becoming a foundational interface for next-generation media systems. As productions get more complex and more talent-driven, the ability to reduce friction while preserving precision will be critical. So in conclusion, voice control is a production system that streamlines broadcast workflows by letting natural language drive real-time graphics and automation. By combining speech recognition, contextual interpretation, and native protocol command dispatch, it gives on-air talent the power to control complex visuals hands-free without waiting on manual intervention. Its first major test came during the election night broadcast, where it proved its reliability, speed, and ability to interpret context accurately. And it was not only a lighter load for operators, but also greater freedom for presenters who could step directly into the role of visual storytellers. And this is just the beginning. Voice control architecture is designed for flexibility with applications across news, sports, weather, and even live virtual events. Looking forward, enhancements like multilingual input, multi-speaker support, and predictive controls will make it even more powerful. As live productions grow in scale and complexity, tools like voice control point the way forward toward workflows that are more intuitive, more efficient, and more interactive. Workflows where creativity isn't slowed by the control room, but extended by the expressive power of speech. Thank you.
I had a question. We haven't had any come in from the audience yet, but I was curious if you're using like a pre-trained vocabulary library or something for like the election night. Are you loading the
Yes.
Yeah,
so we do provide, we do define a domain for it, depending upon the event, depending upon, whatever. So there are some certain keywords that we want to make sure are added to the vocabulary that it can recognize. I'm going to be very interested to see what we can do with it when people are using things like colloquialisms, words like lit, fire, things like this.
There'll be a whole Gen Z vocabulary library you'll have to preload for sure. Excellent. We have no other questions, so thank you very much. It was very informative.
Thank you.